The spring of 1943 arrived at Hömers Dwarf, a German proving ground surrounded by pine forest. Oberingenieur Klaus Reinhardt walked across the damp concrete of the testing yard, his boots leaving dark prints in their wake. Around him lay the accumulated spoils of 3 years of warfare. Captured Soviet T-34s with their distinctive sloped armor still bearing scorch marks from unknown battles. British Shermans waiting under canvas covers for their comprehensive evaluation. American half-tracks with their tracks already removed for detailed measurement. And then there was the truck, the GMC CCK-W, 2.5 tons the Americans called it. Utilitarian, unremarkable, captured in Tunisia and transported across the Mediterranean as little more than a curiosity before landing here at Hömers Dwarf, where someone in Wehrmacht intelligence thought it might reveal something useful about American logistics operations. The olive-drab paint was faded and chipped, desert dust still clinging to the wheel wells. The canvas cover sagged slightly where moisture had collected. Reinhardt circled the vehicle slowly, the way he had learned to approach any testing subject. Observe first, measure second, understand third. 6 tires, all matching. The wheelbase appeared to be around 145 inches. Everything about the design spoke of simplicity. No exotic alloys, no complex mechanical systems evident from external inspection. The hood was flat and functional. The fenders were plain steel, slightly flared. The grille was nothing more than horizontal slats. He opened the driver's door. It swung easily on hinges, showing no sign of wear, despite whatever rough handling the truck had endured in combat and capture. The interior was equally Spartan. A simple bench seat, a basic dashboard with essential gauges, oil pressure, water temperature, fuel level, and amperage. The steering wheel was thin and plain. The gear shift rose from the floor, its pattern embossed on a small metal plate. 5 forward gears, 1 reverse. Reinhardt settled into the seat and reached for the ignition. The engine turned over on the first crank. Not the second attempt, not after pumping the accelerator 3 times. First crank on a cold morning for a vehicle that had been sitting idle for weeks. The inline 6-cylinder engine settled into a smooth idle he could feel through the steering wheel and the floor beneath his boots. He let it warm for a moment, then engaged the clutch. It moved smoothly, with none of the catching and grabbing behavior that plagued even well-maintained German military vehicles. First gear engaged with a clean mechanical click. He released the parking brake and eased the truck forward. The ride quality surprised him. Military vehicles were not designed for comfort. They were designed to carry loads across terrible terrain while being maintained by soldiers who were not mechanics. Yet this truck rode smoothly across the concrete. Its suspension absorbed small irregularities without the harsh impacts he expected. He shifted through the gears, each one engaged cleanly. Second, third, fourth as direct drive, fifth as overdrive for highway cruising. The transmission felt precise and confident, like equipment manufactured by people who knew exactly what they were doing. He drove the truck off the paved surface onto the dirt testing track. Here was where military vehicles revealed their true nature. The GMC handled the transition without drama. The 2-wheel drive configuration meant it was not intended for extreme off-road work, but within its design parameters, the truck performed admirably. The steering responded predictably. The engine had enough torque at low RPM to handle grades without excessive gear changing. After 20 minutes of evaluation, Reinhardt returned to the testing yard and shut off the engine. He sat in silence for a moment, considering. The truck was good. Not exceptional, not brilliant, just solidly, competently good, which raised a question. Why had intelligence sent it here? What were they hoping he would find? He climbed down from the cab and walked to the front of the vehicle. Time for the detailed examination. He opened the hood. The engine bay was clean, not pristine. This was a working military vehicle, but organized. Logical. Each component was accessible. The spark plugs were visible and easy to reach. The distributor cap sat where a mechanic could replace it in minutes. The air filter was a simple oil bath design that could be serviced by anyone with basic training. Reinhardt reached for his toolkit and selected a socket wrench. He would start with something simple, remove a spark plug, check the gap, examine the threads. Standard procedure for engine evaluation. The plug came out smoothly. The threads were clean and precise. The gap was exactly as specified in the manual that accompanied the truck, 0.035 inches. He set the plug on a clean cloth and selected another socket. Second plug, identical condition. Identical gap. Third plug, fourth, fifth, sixth. Every spark plug in the engine was manufactured to the same exacting standard. Not approximately the same, exactly the same. Reinhardt straightened and looked across the testing yard. Another GMC sat near the perimeter fence, captured in Sicily, arrived 2 weeks earlier. According to its data plate, it had been built in a different factory. Pontiac, Michigan, not St. Louis, Missouri. Manufactured in December of 1942, 3 months before this truck. He walked across the yard and opened that truck's hood, selected a spark plug at random, removed it, held it next to the plug from the first truck. Identical. Not similar. Identical. Same manufacturer marking, same heat range, same thread pitch, same reach, same hex size. He could have closed his eyes and been unable to tell which plug came from which truck. He walked back to the first GMC and tried an experiment. There would have been no point with German vehicles. He took the spark plug from the Sicily truck and threaded it into the Tunisia truck's engine. It fit perfectly. The threads engaged smoothly, precisely, with the exact resistance that indicated proper manufacturing tolerances. No forcing, no cross-threading, no need for careful alignment. Something cold was forming in Reinhardt's chest. He moved to the distributor cap, removed it from the first truck. He walked to the second truck, removed that distributor cap. He brought them together. They were interchangeable. He tried it. The cap from the Pontiac truck fit the engine from the St. Louis truck as if they had been manufactured as a match set. He checked the rotor. Interchangeable. The coil wire. Interchangeable. Every component he tested showed the same impossible precision. He returned to his office in the testing facility's main building and sat at his desk. His notes lay open before him. He had written utilitarian, nothing impressive, in his initial assessment. Now he picked up his pen and added new lines. The words came slowly because he was trying to understand what he had discovered. This was not just a well-made truck. This was not even just a precisely manufactured truck. This was something that should not be possible. The interchangeability across factories, across time, across thousands of miles of separation. He had seen German manufacturing. He had watched Opel Blitz trucks come off assembly lines at Brandenburg. Even vehicles built in the same factory on the same day required adjustment, filing, fitting. Mechanics kept files and hammers nearby because components never quite matched perfectly. It was normal. It was expected. It was the nature of manufacturing. You built to tolerances and then you adjusted during assembly. That was how things worked. Except the Americans had apparently decided that was not how things should work. They had created a system where adjustment was unnecessary, where every part from every factory fit every vehicle perfectly, where a mechanic in North Africa could salvage a part from a wrecked truck and install it in a different truck without any modification. The implications were staggering. Reinhardt reached for the intelligence request forms. He needed production data. He needed to know how many of these trucks existed, because if the Americans could manufacture components with this level of precision at scale, then they had achieved something Germany had never attempted, something Germany might not be capable of attempting. He filled out the forms carefully, specifying exactly what information he needed. All factories and locations, production rates, total units manufactured, component sourcing, quality control procedures, everything that might explain how the Americans had accomplished what German engineers had assumed was impossible. He sealed the request and sent it through channels to Wehrmacht intelligence headquarters. The response would take days, perhaps a week. He returned to the testing yard and spent the rest of the afternoon documenting every dimension, every specification of the GMC truck. The numbers were all clean, rounded, simple. 104 horsepower, 7,532 pounds, 145-inch wheelbase. As if the Americans had decided that convenient numbers mattered more than optimized performance. When the sun set behind the pine trees and the spring chill returned to the air, Reinhardt locked his office and walked to his quarters. He did not sleep well that night. He kept thinking about those spark plugs, those perfect, identical, interchangeable spark plugs. He wondered what the production numbers would reveal when they arrived. The intelligence report came on a Thursday morning, 6 days after Reinhardt had submitted his request. The manila envelope was marked with standard Wehrmacht classifications and routing stamps, but it was thicker than he had expected. He opened it at his desk and began reading. The first page was a summary, an assessment compiled from multiple sources. Aerial reconnaissance over American industrial centers, captured production documents from Tunisia and Sicily, interrogations of American prisoners who had worked in automotive factories before conscription, analyses from German intelligence officers operating in neutral countries with access to American trade publications. The numbers began simply enough. GMC CCK-W production commenced in February of 1941. First-year output, approximately 82,000 units. Reinhardt stopped and examined that number once more. 82,000 trucks of a single model, manufactured by one company in just 12 months. He kept reading, his eyes moving across the page. The 1942 production figures jumped out at him. 160,000 units built. Then came the projection for 1943, based on current factory capabilities and what observers were actually seeing roll off the assembly lines. 190,000 trucks expected to arrive that year. The report made clear these numbers applied only to the GMC CCK-W model, just one American truck type among many others. There was also the Studebaker US-6, the Chevrolet G7107, Dodge's WC series, and various models from Federal Motor Companies. He flipped to page 2, where the real comparison began. German military truck output for all manufacturers combined in 1942 came to roughly 78,000 units across the entire year. Germany's finest military truck, the Opel Blitz, had managed somewhere between 100 and 130,000 units since 1940. The complete production run. All years combined. Here was the stark reality. Americans were manufacturing more of a single truck model in 12 months than Germany had produced of its most successful design over 3 years. Reinhardt set the report down and walked toward the window. Below, mechanics worked steadily on a Panzer IV, performing maintenance checks. Competent men, technically skilled, laboring over machinery that was both advanced and genuinely effective. He observed them briefly, then returned to his desk to continue absorbing the pages before him. Page 3 laid out American manufacturing methods. The information came from interrogated prisoners and seized paperwork, so gaps existed, yet certain patterns became unmistakable. 2 primary locations handled GMC CCK-W assembly: Pontiac, Michigan, and St. Louis, Missouri. Dozens of supplier workshops scattered across the American Midwest produced additional components. What Reinhardt had observed about part standardization was no accident. It formed the very foundation of the American production philosophy. Every single component was built to such exacting specifications that parts manufactured anywhere fit into any vehicle without any adjustment needed. This created advantages the report listed with precise clinical language. First came simplified logistics. Replacement parts moved in bulk shipments without needing to match specific vehicles. A warehouse holding one distributor cap design knew that part would work on every GMC in active service. Second, reduced mechanic training. Workers did not need to memorize the peculiarities of different production batches. All trucks were essentially identical. Third, faster repairs. No adjusting, no filing, no fitting required. Swap out the damaged part, install the replacement, send the truck back to work. Fourth, production savings. Making millions of identical pieces cost far less per unit than manufacturing limited quantities of varied components. A photograph accompanied the text, grainy from multiple reproductions, showing part of the Willow Run manufacturing facility in Michigan. The caption identified it as a bomber production line. B-24 Liberators coming together at a speed of one finished aircraft every 63 minutes. 42,000 workers staffed this facility. Most were women, few had ever worked manufacturing jobs before 1942. Yet they assembled 4 engine bombers containing over 1 million individual parts each. The caption noted that the GMC truck facility in Pontiac, visible in aerial reconnaissance photographs next to other GM plants, appeared to match this scale and operated using identical principles. Reinhardt heard footsteps outside his office, followed by a knock. He granted entry. Hauptmann Friedrich Weber stepped through, closing the door. Weber had recently arrived at Hömers Dwarf, transferred from combat in North Africa after the campaign concluded in May. Early 40s, wiry and sunburned, with the careful movements of someone trained to preserve strength through desert conditions. Weber indicated the chair opposite Reinhardt's desk. "May I sit?" Reinhardt gestured approval, and Weber settled into the seat. "I learned you were studying American production numbers. I thought perhaps the intelligence from the field might provide context for those figures." Reinhardt slid the report across the desk. Weber examined the opening page, then looked up. "These estimates are too low," he said. "I witnessed the convoys moving toward North Africa, Sicily, in those final months. Watch them long enough, and you never saw matching vehicles. Identical trucks, certainly, but varying serial numbers, different units. The stream simply never ended." "What did you observe?" Reinhardt asked. Weber settled back thoughtfully. "Americans handle vehicles in an entirely different manner than we do. When a German unit loses a truck, it becomes an emergency. We salvage parts from wrecked machines, improvise repairs, keep vehicles operating well beyond their intended lifespan because finding replacements remains uncertain. Americans approach it differently." He paused. "They leave repairable trucks behind. I saw it myself. A GMC with a damaged axle abandoned beside the road. Not destroyed, not trapped with explosives, simply abandoned because fetching a replacement vehicle proved faster than fixing the damaged one." "That's wasteful," Reinhardt observed. "No," Weber replied. "That's wealth. They possess more trucks than necessary. More trucks than we possess the capacity to destroy. During Kasserine Pass, we struck an American convoy, eliminated roughly 20 vehicles, captured another 15. Our command celebrated what they believed was serious damage to enemy supply operations. 48 hours later, that same road carried twice the truck traffic. They simply moved additional vehicles forward." Reinhardt thought of those spark plugs, those interchangeable pieces. The system Weber described suddenly made complete sense. When every truck matched every other truck and replacement arrived effortlessly, repair became a straightforward question. Could this vehicle be fixed faster than a replacement could arrive? If not, discard it and continue. The system eliminated the careful preservation scarcity demanded. German logistics assumed every vehicle held precious value. American logistics treated vehicles as consumable ammunition. Weber continued, "You should understand something else about this. The effect on soldiers' thinking. German troops grasp our supply situation. They understand trucks remain scarce. They know parts availability is limited. They recognize that if equipment fails, weeks might pass before repairs happen. American soldiers experience something entirely opposite. Equipment breaks, it gets replaced within hours. They observe endless supply columns arriving constantly. They become convinced their industry can produce anything demanded, and they happen to be absolutely correct." Reinhardt picked up the report again and turned to page 4, examining component specifications. The GMC 270 engine was an inline 6-cylinder with valves positioned overhead. Displacement measured 269.5 cubic inches. GMC had been manufacturing similar commercial truck engines since the 1930s. The transmission, a Warner T935 5-speed unit, originated from commercial production as well. Transfer cases, axles, braking mechanisms, each one represented careful refinement of established designs rather than radical innovation. The Americans had not invented entirely new technology for this truck. They had taken components with proven track records and optimized them for mass manufacturing and reliability. "They're not engineering the most capable truck," Reinhardt said quietly to himself. "They're engineering the maximum number of trucks." Weber nodded in agreement. "Precisely, and it functions. A Tiger tank defeats a Sherman in direct combat, but we produce one Tiger for every 50 Shermans they manufacture. They build 200 trucks to supply each Sherman company. When tactical superiority exists in that ratio, strategic impact evaporates. Reinhardt turned to the final page. Recommendations followed from the intelligence office. Recommendation 1. Germany should investigate reverse engineering American standardization approaches. Recommendation 2. German manufacturers should consolidate production around fewer truck models to increase efficiency. Recommendation 3. Machine tool production should expand to enable precision manufacturing at volume. Each recommendation included a feasibility assessment, and none offered encouragement. Reverse engineering American standardization would demand rebuilding the entire German automotive sector. Estimated timeline, 3 to 5 years, assuming no interference from Allied bombing raids. Consolidating truck production around limited models meant scrapping current manufacturing equipment and retraining the workforce. Production losses during the changeover period would likely reach 40 to 60% for 12 to 18 months. Expanding machine tool capacity required materials Germany lacked and time Germany no longer possessed. The report concluded with a single sentence Reinhardt read repeatedly. American manufacturing capacity represents a strategic advantage that cannot be defeated by operational skill or tactical ingenuity. Weber rose to depart. One additional matter: the trucks carry governors, speed limiters, restricted to 35 miles per hour. The Americans have deactivated them. Supply vehicles travel at 60 miles per hour, sometimes faster. They understand their engines can endure this stress because they trust their production standards. Our trucks possess no governors because our engines cannot sustain velocity reliably enough to warrant them. After Weber departed, Reinhardt remained in his office as daylight faded into darkness. His thoughts turned to machine tool capacity and manufacturing infrastructure. Germany possessed capable engineers, truly excellent ones, yet precision production at enormous scale demanded more than engineering talent. It required industrial systems requiring years to construct. The Americans had begun developing that infrastructure during the 1920s and 30s while at peace, propelled by commercial automotive rivalry among Ford, General Motors, and Chrysler. For decades, they had perfected manufacturing millions of vehicles with standardized components because civilian purchasers demanded dependability and service centers needed simplified maintenance procedures. Germany had spent those identical decades nurturing craftsman heritage, specialized production, customized assembly, remarkable engineering, sophisticated yet not scalable. The Americans had selected a different path, and they had committed to that choice 2 decades prior to the conflict's beginning. The GMC truck sitting in Kummersdorf's testing yard represented far more than just transportation equipment. It embodied 2 decades of industrial philosophy expressed in metal and rubber. That philosophy had already determined the war's outcome. Germany merely remained unaware. By August 1944, the calculations transformed from theoretical production statistics into tangible battlefield circumstances. Reinhardt received intelligence dispatches from France with growing regularity, each detailing American supply operations that should have proven impossible to execute. Allied breakthrough from Normandy happened in late July. Within 14 days, American forces operated 100 miles deeper into France than the invasion beaches. Military theory maintained such rapid movement would trigger a supply catastrophe. Fuel would run short, ammunition would vanish, supply routes would exceed sustainable capacity, then collapse, enabling defending forces to counterattack and reclaim territory. Yet the expected collapse simply failed to materialize. Instead, intelligence reports reaching Reinhardt described something unprecedented. Americans had established what they termed the Red Ball Express. The terminology derived from railroad operations. Red Ball freight represented priority shipments traveling dedicated rails without interruption. Americans had transferred this principle to truck operations. They designated particular routes as exclusively one-way roads, restricted entirely to resupply convoys. Northbound roads moved supplies ahead toward fighting units. Southbound roads returned empty vehicles to the beaches. All other traffic was forbidden. No exemptions existed. Intelligence summaries arriving on Reinhardt's desk in mid-August presented operational information gathered from various sources. 6,000 trucks operated in constant rotation. Daily delivery reached 12,500 tons of supplies. Round-trip mileage totaled roughly 300 miles. Operations continued 24 hours daily without pause. The dispatch indicated the operation had maintained continuous function since August 25th, with no planned termination. The tonnage numbers defied comprehension. 12,500 tons daily translated to 375,000 tons monthly. The entire German Eastern Front, stretching from Baltic shores to Black Sea coasts, required approximately 15,000 tons daily using trucks, rail transport, and animal-drawn vehicles combined. Reinhardt unfolded a map of France across his desk. Normandy to Paris measured roughly 150 miles. American forces were now operating east of Paris, meaning supply runs extended beyond 200 miles per leg. 400 miles total for round trips. Trucks traveling at approximately 40 miles per hour measured against French road conditions. 10 hours driving time alone, excluding loading periods and unloading operations. Keeping the supply lines running meant the military had to constantly swap out trucks and assign fresh drivers to the routes. Weber knocked, then pushed straight into Reinhardt's office without waiting to be invited. He carried a thick folder stuffed with papers. Fresh intelligence from France, Weber announced, laying the folder across Reinhardt's desk with purpose. Operation orders for Red Ball Express units sat alongside maintenance schedules and driver rosters, creating a complete picture of how the entire system functioned. Reinhardt opened the folder carefully. The first document bore an operation order dated August 29, 1944, issued to Red Ball Express units. He studied the daily figures with growing attention. Nearly 6,000 trucks were actively running that day. Over 12,000 tons of supplies had been delivered. The effort required coordinating 132 separate truck companies working in concert. Supporting all these vehicles were 23,000 drivers and mechanics, Reinhardt said aloud, absorbing the scale. Just one supply operation. The paperwork identified this as a peak performance day, yet even ordinary days showed delivery figures well above 10,000 tons. Look at how they handle the maintenance side, Weber said, pointing to another document in the stack. Trucks move through service stations every 72 hours. Oil gets changed, brakes get inspected, tires rotate. Nothing happens by accident. It's like treating trucks as ammunition, Reinhardt observed. You fire them hard, you service them on a fixed schedule, and when one fails completely, you swap it out for another one. The entire setup treats vehicles as things you use up. Reinhardt found the maintenance document and studied it carefully. The system was elegant in its simplicity. Trucks would be pulled from active routes in groups, sent to mobile service units for work, and returned to duty within a day. For repairs taking longer than 24 hours, replacement vehicles came from reserve pools sitting nearby. This prevented repair backlogs from slowing operations. Reserve pools, Reinhardt repeated to himself. The Americans maintained stockpiles of extra trucks specifically to take over when others needed fixing. The next document showed personnel records for a single truck company. It listed 273 people total. Most of these men were African-American soldiers, a detail the German intelligence officers had noted because their segregated command structure seemed noteworthy to them. What struck Reinhardt more forcefully was the ages listed beside each name. 3/4 of these drivers had not yet reached their 24th birthday. Many had notes indicating Army-provided commercial driving training. These were not seasoned professionals. They were kids, many raised in rural areas where they had never sat behind the wheel of a truck before enlisting. Now they drove the lifeblood of American operations in Europe. The Americans schooled them in a matter of weeks, Weber said, his tone suggesting amazement. German logistics personnel study for months because they need to master different truck models, various maintenance procedures, ways to improvise repairs in the field. Your Red Bull driver? He learns one thing: how to drive his assigned truck, and how to stay in convoy formation. Nothing more. If his truck breaks, someone else takes over the repair or brings in a replacement vehicle. Reinhardt turned to another document pulled from the captured files. This one was a maintenance manual, probably 100 pages with its spiral binding and simple illustrated drawings showing basic steps. oil drain plugs, filter replacement, refill amounts, tire changes and jack points, electrical system basics, fuse boxes and headlight replacement. The manual spoke to someone with zero mechanical background. The truck was treated as a simple system, certain tasks anyone could manage by following instructions. Everything beyond that went to trained mechanics. Compared mentally to German truck documentation, the contrast was striking. Germany's Opel Blitz manual stretched over 600 pages, covering multiple variants produced across several years. It expected mechanics to understand automotive principles, diagnose issues through examination and testing, make detailed adjustments to components, and compensate for manufacturing differences. The American manual assumed trucks either worked as intended or they did not. No gray area requiring a skilled technician's judgment. There's something else you need to consider, Weber said, producing a battlefield report from a German panzer unit that had fought supply convoys in early September. We took some GMC trucks intact. Our mechanics tried restoring them using parts from other captured vehicles. A Chevrolet engine piece fit the GMC mounting points. Dodge electrical connectors matched up with GMC wiring. The Americans had apparently designed their entire truck fleet with parts that could swap between models. Reinhardt had missed this implication entirely. What he thought was design standardization within a single model extended across different makers. General Motors, Chrysler, and other American automotive manufacturers had worked together on military production, ensuring components would interchange across the board. A German mechanic working on captured American vehicles could grab parts from different truck makers because the whole system had been engineered for compatibility. Our own soldiers request captured American trucks instead of our equipment when they have a choice, Weber continued. Field reports say they prefer the reliability, simpler maintenance, better comfort. We have instances of German units leaving working Opel Blitz trucks behind just to drive captured GMCs instead. The meaning hit hard. German soldiers, when given options, chose enemy equipment over their own nation's trucks. Not because American vehicles were inherently more advanced, they were not, but because they worked more consistently, required less fussing, stayed reliable longer, broke down less often, and parts were easier to find. Reinhardt opened another captured document. This one was an intelligence assessment covering American vehicle manufacturing through mid-1944. American truck production since 1940 exceeded 2 million units. Monthly output currently ran about 200,000 trucks across all producers. Germany had built roughly 347,000 military trucks across the entire conflict. America was manufacturing more trucks every 2 months than Germany had produced in 4 years. The figures are worse than they appear on paper, Reinhardt said quietly. The actual experience on the ground makes these numbers even more brutal, Weber answered. You destroy an American convoy and another one appears the following day. You capture their trucks and they run better for you than our own vehicles do. You cut a supply route and the Americans build a different route. You cannot stop this. You cannot disrupt it. Their logistics capacity exceeds anything we can do to break it. Reinhardt shut the folder and studied the map of France spread across his desk. Red lines showing American advance paths looked like blood vessels pumping life through a body. Thousands of trucks moved supplies forward constantly, fueling each push deeper into France. The German army had won tactical fights all summer. They had fought with skill, inflicted American casualties, temporarily slowed American movements. None of it mattered in the end. The trucks kept rolling. Supplies kept flowing. American advances continued not because German resistance had crumbled, but because American logistics made German retreat unavoidable. There is one additional point, Weber said. He indicated a notation in the operation order. Red Ball Express is not their only operation. They run other smaller convoy systems, move supplies by rail, use aircraft, employ coastal shipping routes. Red Ball is just their emergency response when regular supply channels cannot keep up with their own speed. This entire thing, 6,000 trucks, 23,000 people, 12,000 tons daily, is their backup plan they threw together in a few weeks. Reinhardt pictured what their main logistics system must look like. If Red Bull was merely the emergency backup, what capacity did the ordinary American supply system possess? He considered the GMC truck sitting in the testing yard nearby, the one being evaluated. That single vehicle came from a production run now counting hundreds of thousands of units. One truck that had traveled from a factory in Michigan or Missouri to a North African battlefield to a German testing facility, and it still performed flawlessly. Multiply that reliability across 500,000 trucks. Multiply that parts compatibility by millions of components. Multiply that factory capacity by several dozen manufacturers. The result was not an army. It was an industrial tidal wave that crushed everything beneath its sheer accumulated weight. A comprehensive assessment arrived at Reinhardt's desk in late October of 1944. Months of German intelligence analysis compiled into one report. The cover memorandum stated the enclosed information represented worst-case findings based on confirmed facts rather than educated guesses. Reinhardt opened the pages and started reading. Within 3 pages, he understood there was no best-case scenario here. These numbers offered no optimistic reading. American military vehicle production from 1940 through September 1944 totaled 2,455,964 units. The breakdown was systematic. Military trucks comprised 2,400,000 of these. Jeeps numbered 650,000. Half-tracks, amphibious carriers, and specialized vehicles pushed the count higher. Just the GMC CCK-W trucks alone represented between 520,000 and 560,000 units, depending on which production records seemed most trustworthy. One truck model from one company exceeded Germany's entire military truck output across all makers for the whole war. Reinhardt moved to the comparative analysis pages. German military truck production from 1939 through September 1944 totaled 347,490 units. The major models were Opel Blitz at roughly 130,000, Mercedes-Benz L3000 at about 80,000, and various smaller producers making up the remainder. The math was brutally simple. Americans had produced 7 trucks for every German truck built. In 1944 alone, American factories built more trucks than Germany had manufactured across the entire war. The report's next section examined operational availability, the actual percentage of vehicles ready to fight on any given day. American trucks maintained 80 to 90% readiness. German trucks achieved 60% under good conditions, often dropping below 40% in combat zones where parts ran short and maintenance fell behind. This meant the real ratio was not 7 to 1, but closer to 10 to 1. An American unit listing 100 trucks would have 85 to 90 running. A German unit with 100 would have 50 to 60 operational. The strategic implications section spelled out what Reinhardt had been thinking for months. American forces could absorb vehicle losses that would paralyze Germany. Destroying 1,000 American trucks meant almost nothing. Americans built more than 1,000 trucks daily. They absorbed such losses without changing their operations. German forces losing 1,000 trucks faced catastrophic crisis. Replacement trucks did not exist. Units would sit immobilized, supply chains would collapse. The gap was total. Reinhardt found Weber back in the testing yard, examining a recently captured Studebaker US-6 truck. "You have to look through this report," Reinhardt said, handing over the folder. Weber skimmed the opening pages, his face remaining neutral. Years of battlefield reality had made him immune to shocking statistics. "There is a Panzer commander's assessment in the back sections," Weber said. "I saw an early version. Find it when you get the chance." He handed the report back and went back to studying the Studebaker's suspension components. Reinhardt returned to his office and found the annex. The report came from a Tiger Tank Battalion commander whose name had been removed. Dated October 15, 1944. The assessment was straightforward and grim. "We possess the ability to destroy their tanks," the officer wrote. "A Tiger at distance enjoys significant advantage against Shermans, but we cannot destroy their supply system. For each Tiger we deploy, they send 50 trucks. Those trucks bring fuel, ammunition, replacement tanks faster than we can eliminate them. Tactical superiority becomes meaningless when enemies replace losses endlessly, and we cannot. The report included specific incidents. Recently, the battalion had destroyed 17 Sherman tanks. The Americans withdrew, reorganized, and returned 12 hours later with more tanks than they had lost. German units losing 17 tanks might wait weeks for replacements, assuming replacements even existed. The equation had no solution. German tanks were superior. German tactics were superior. German crews possessed more experience. It made no difference when Americans replaced their losses overnight and Germany could not. Reinhardt turned to the next section, analyzing the Ardennes offensive, planned for December. The operation assumed German forces would capture American fuel stocks because German trucks could not deliver enough fuel to sustain armored advances. The plan depended on seizing American gasoline to keep German tanks moving. It admitted German logistics could not support the required supply rates. The entire plan rested on desperation: attack with available forces, maintain momentum using captured resources, hope the enemy cracks before captured supplies run dry. Reinhardt absorbed the implications. Germany was planning a major operation based on the belief that American logistics were so abundant that stealing from them was more reliable than using German supply systems. Before the battle even started, the plan conceded defeat. It admitted German trucks could not compete with American trucks, that German logistics could not match American logistics, that the only possible path to success was taking what America had already built. The report contained reconnaissance photographs taken over American rear areas in France. Reinhardt examined them through a magnifying glass with mounting dread. The sprawling, vast supply depot stretched across what had once been open farmland. Thousands of vehicles sat in neat, orderly rows. Tarps covered mountains of supplies, while fuel tanks clustered in designated zones near the railway lines. The sheer magnitude of it all was staggering. One photograph alone captured an estimated 400 trucks filling a single storage area. The intelligence notes made clear this wasn't even their main logistics hub, just a reserve motor pool for one sector. 400 trucks held in reserve. Germany would view 400 trucks as sufficient to supply an entire army corps. The Americans filed it away as extra capacity for one part of one battlefield. A second photograph showed port operations, likely at a major harbor based on the geographic markers visible in the image. Ships stood at dock while their cargo flowed directly onto waiting trucks. Cranes moved steadily, transferring crates and supplies from ship holds to vehicle beds. Operations ran around the clock without pause. The intelligence assessment pegged this single port's capacity at 8,000 tons daily. Germany's entire railway system, despite constant bombing runs from Allied aircraft, struggled to push 15,000 tons per day across all their fronts combined. Reinhardt turned to the final assessment section. It was concise and devastating. American industrial capacity represents an insurmountable strategic advantage. Current German production cannot increase sufficiently to achieve parity. Allied bombing systematically degrades existing German manufacturing capacity. No tactical skill or operational excellence can overcome a 10-to-1 material disadvantage that expands with each passing month. He set the report down and sat motionless. Afternoon light angled through the office window, illuminating dust particles floating in the stillness. Beyond the glass, mechanics were working on a Panther tank. Dedicated men maintaining excellent machinery. The Panther was a remarkable tank, arguably the finest medium tank in existence. Germany had built roughly 6,000 Panthers. America had produced 49,000 Shermans and 2 million trucks to supply those Shermans. Weber appeared in the office entrance. "I thought you'd want to know. The GMC in Bay 3 just reached its 500th hour of continuous testing. Original engine, original transmission, nothing requiring major overhaul. Our Opel Blitz trucks need complete rebuilds at 300 hours. Reinhardt nodded slowly. 500 consecutive hours on a vehicle that had already seen combat service before falling into German hands. The truck kept running on components manufactured in Michigan or Missouri back in early 1943. Nearly 2 years in service, moved between theaters, captured, put through rigorous testing protocols, and still performing reliably enough to meet German verification standards." "Something else," Weber said. He stepped inside and closed the door. I got a letter from someone still in the field. His unit captured several GMC trucks last week in working condition. They're running supply operations with them because they're more dependable than our own vehicles. But here's what matters. Those trucks have serial numbers in the 6 million range. Reinhardt felt ice settle in his stomach. 6 million? Serial number 6423, A817 specifically. That's what my colleague wrote down. The Americans stamp serial numbers that high because they've made that many vehicles. Not just trucks, all military vehicles combined. 6 million total. Reinhardt grabbed a notebook and worked through the numbers. 6 million vehicles built over roughly 4 years. That worked out to 1.5 million annually, roughly 125,000 monthly, 4,000 daily, every single day, Sundays, Saturdays, holidays included. 4,000 military vehicles emerged from American factories every 24 hours. Germany's total truck production across the entire war came to 347,000 units. The Americans produced that much in 3 months. We're not testing enemy equipment anymore. Reinhardt spoke quietly into the silence. We're documenting the weapon that defeated us. Weber offered no response. There was nothing left to say. The mathematics admitted no argument. The Americans hadn't prevailed through tactical brilliance or technological advancement. They'd prevailed through deliberate, systematic industrial power developed across peaceful decades. They'd won because Henry Ford had perfected the assembly line 3 decades earlier, and American industry had spent those 30 years refining mass manufacturing. They'd won because common trucks, produced by the hundreds of thousands, outmatched sophisticated trucks, produced by tens of thousands. They'd won because in modern warfare, the system always triumphs over the masterwork. Reinhardt opened his testing log and entered the day's data. The GMC remained operational after 500 hours of testing. Systems functioned within acceptable ranges, no notable degradation. He recorded the date, October 28, 1944, and closed the log. Tomorrow the testing would resume. He would record specifications. He would measure precision tolerances. He would prepare additional reports. Yet the verdict was already determined. Germany lost when the first GMC rolled off an American line in February 1941. Everything afterward was merely accounting for the consequences. The evacuation directive for Hömers Dwarf came through in early April 1945. Soviet armies pushed westward, while German facilities around Berlin faced systematic destruction to deny them to the enemy. Reinhardt spent his last weeks there cataloguing records, arranging for equipment transfer or destruction, and guaranteeing nothing of strategic value would reach Soviet forces. The captured vehicles would burn. The testing apparatus would burn. The structures would stand empty under Soviet control. 4 years of effort transformed into rubble and abandoned buildings. On a crisp spring morning, he made a final walk through the testing yard. The GMC truck remained parked where mechanics had kept it serviceable throughout its time at Hömers Dwarf. They'd used it periodically for facility work when German vehicles weren't available. Its odometer displayed over 15,000 miles accumulated through capture, transport, and testing phases. The truck still ran with the same smoothness it had shown on the morning Reinhardt first fired its engine. He climbed into the cab and gripped the steering wheel, peering out across the proving ground he'd never visit again. German engineering philosophy had created magnificent machines. The Tiger tank embodied this: superior armor, superior firepower, superior construction. Germany had produced 1,347 Tigers, counting both Tiger I and Tiger II production. The Americans built 49,234 Sherman tanks, not superior tanks, merely adequate tanks that appeared in such overwhelming quantity that superiority ceased to matter. This truck beneath him followed the identical principle. Not the finest truck, just sufficiently good truck manufactured at volumes that made quality distinction meaningless. Reinhardt had invested months assembling a comprehensive analysis of American manufacturing approaches, finished in February before Germany's disintegration made such work futile. This report catalogued his discoveries: the standardization enabling component interchange, the simplified architectures accelerating manufacturing, the enormous machine tool expansion creating precision at volume. the commercial vehicle expertise enabling military production without major retooling. All pathways led to identical reasoning. America had prevailed in the industrial preparation competition during peace, and Germany could never bridge that gap during conflict. The report contained sections on post-war consequences that Reinhardt understood no one with decision authority would ever examine. Yet he'd composed them anyway because professionals recorded facts regardless of whether audiences would listen. The Americans had proven that modern warfare centers on industrial systems rather than battlefield brilliance. Future confrontations between developed nations would replicate this dynamic. Whoever commanded greater manufacturing capacity, superior standardization practices, and streamlined supply routes would triumph regardless of individual weapon excellence. The masterwork perpetually loses to the mass-produced apparatus. He considered the Red Ball Express operation, 82 days of uninterrupted transport, delivering 412,000 tons. That volume could sustain 28 divisions for 3 months. Without those trucks, American momentum from Normandy would have halted. With them, American forces reached German territory before winter arrived. The ordinary 2.5-ton truck generated greater strategic impact than any wonder weapon Germany conceived. Not the V-2 rocket, not jet aircraft, not massive tanks could equal the strategic significance of 500,000 trucks distributing supplies to precisely the right locations at precisely the right moments. Reinhardt descended and returned to his office. Weber was there, gathering his own materials for departure. They'd occupied this space together, tracking Germany's deterioration through intelligence summaries and captured equipment reviews. Weber glanced up. Soviet forces arrive within days. Weber said, "They'll locate these American vehicles we didn't destroy in time. They'll evaluate them exactly as we have, reaching identical conclusions." "They're already informed," Reinhardt replied. Lend-Lease delivered 152,000 American trucks to Soviet supply lines, Studebaker US-6 models. The Soviets treasured them, considering them their finest trucks. Following the war, they'll replicate the designs, manufacturing their own variants. America educated the Soviets in proper military transport logistics. Weber gathered his papers into a weathered leather folder. "What happens next for you?" "Westward," Reinhardt answered. "I'll surrender to American or British forces rather than risk Soviet capture." "And yourself?" "The same, though I wonder how Americans will treat German engineers. We devoted 4 years studying their equipment. Perhaps they'll want explanations for why we couldn't match it." Reinhardt contemplated this possibility. Americans would definitely conduct extensive interrogations. They'd want details about German weapons work, manufacturing facilities, production approaches. They'd discover Germany had prioritized sophistication over standardization, exclusive quality over abundant quantity, architectural perfection over functional system. They'd confirm their own strategy had proven correct. The American approach, streamlined designs, assembly line manufacturing, plentiful inventory, bore vindication through conquest. The ultimate irony lay in Germany's partial pre-war understanding of these concepts. Opel operated as a General Motors subsidiary. GM had transported American production techniques to Germany during the 20s and 30s. The Opel Blitz incorporated American-influenced design philosophy, yet Germany never fully embraced this approach. German tradition championed individual craftsmanship, precise fitting, intricate engineering. These traditions generated exceptional machinery but insufficient quantity. Americans traded exceptional for plentiful, and plentiful prevailed. Reinhardt locked the office one final time and proceeded toward the evacuation convoy forming outside. He carried a single case, holding his personal documents and his final report's duplicate. The original had gone to Wehrmacht command in January, likely buried in archives or destroyed by bombing raids. This copy would endure as his personal testimony, recording that American industrial strength surpassed all comparison in fundamental character. That standardization and component compatibility outweighed engineering distinction. That the modest GMC truck wielded greater strategic force than the Tiger tank. That Germany had lost before commencing because America had invested peacetime constructing industrial foundations while Germany scrambled to establish them during wartime. The convoy started moving as distant Soviet artillery thundered. Reinhardt looked back once at Hömers Dwarf's testing grounds, where 4 years had passed examining captured machinery. The GMC would greet the Soviets upon arrival. They would measure it, assess it, record their findings, and determine identical truths. That logistics dominated modern conflict. That logistics demanded standardization. That standardization necessitated industrial development. That industrial development demanded decades of peacetime investment. America recognized this. Germany had not. The distinction appeared in millions of trucks, billions of supply tons, and the distance separating Detroit from Berlin. By 1953, American military historians studying German wartime equipment assessments interviewed Reinhardt. He recounted testing the GMC truck, discovering the remarkable component standardization, reviewing production statistics, and grasping their meaning. Did German engineering possess capacity for American manufacturing output, given sufficient time and materials, the interviewer wondered? Reinhardt answered truthfully, German engineering produced magnificent works. American engineering produced mechanisms. Modern warfare demands mechanisms. The magnificent work cannot withstand the mechanism because mechanisms absorb destruction, maintain function, and regenerate faster than enemies destroy them. That represented no German engineering shortcoming. It reflected American strategic wisdom. They created trucks that performed adequately, generated them in staggering numbers, and secured victory through mathematics rather than artistry. The GMC CCK-W remained serviceable in American forces through 1956. 2 decades of operation from a truck conceived through hurried, 36-hour design in 1941. Some continued functioning in Allied militaries extending into the 90s. The plainest American truck outlasted the most complex German tank by many years. Not through superior engineering, but through superior conception. Adequate performance at impossible scale defeated perfection at limited production. The ordinary truck conquered the war, and every nation recognizing this principle restructured military manufacturing accordingly. The era of the masterwork concluded. The era of the system commenced, launching in a Michigan factory in February 1941, when manufacturing commenced on the inaugural GMC.